In the previous lecture, we have done step 1 to fire up a console container as a key value for service discovery. Now, we can move on to step 2 to provision a Docker Swarm master node. If you have using a different terminal session than the previous lecture, you need to reset those environment variables as we did in the previous lecture. Let's start by creating the Swarm master host. A Swarm cluster consists of a master node, which is effectively the Swarm manager, and an arbitrary number of ordinary nodes. Swarm manager is responsible for the entire cluster and manages the resources of multiple nodes at scale. The Swarm master flag is used to identify this node as the Swarm master. We also need to provide the console endpoint as the --swarm-discovery flag. The --swarm-discovery flag instructs the created swarm node to look for the created key value store using the specified address, and protocol, which allows the instances of the swarm to find and communicate with each other. --engine-opt option allows us to set the Docker daemon flags. Here we have 2 flags to set. The first one is --cluster-store flag, which instructs the Docker daemon which key value store to use for cluster coordination. The other one is --cluster-advertise, which provides an address that the created Docker daemon should advertise as connectable to the cluster using the key value store. Finally, we'll name this host master. Now Docker machine is provisioning the host on DigitalOcean. I'm fast-forwarding the video until the process is completed. Now the Swarm master node has been created. Let's move on to create slave nodes in the Swarm cluster. We can create any number of slave nodes in this swarm. In this lecture, we just create one node called slave. The command we use to create the slave node is very similar to the one we use to create the Swarm master. The only difference is that we don't specify the --swarm-master flag, so the Docker machine knows we're creating a normal node in the cluster. Now the slave machine is provisioned. Let's connect our Docker client to the Swarm master. Then we run Docker machine ls to check all current running hosts. See, we get 3 hosts running on DigitalOcean: the console, the Swarm master, and Swarm slave. Now let's check the Swarm cluster information by running docker info command. As you see, we have 2 nodes, the master node and slave node. But we have 3 containers up running. Let's find out why. Just do docker ps-a to find out all containers. See, we have Swarm agent running on the slave host. And we have both Swarm agent and Swarm manager running on the master host. What it means is that the master host is a slave node as well as a master node. It's responsible to decide which host to run containers, and it can also run containers on itself. Now we have done step 2 and step 3 to provision a Docker Swarm cluster, which consists of a master and a slave node. Let's move on to step 4, to define the overlay network to support multi-host networking. This can be done by modifying our Docker Compose file. Before we define the overlay network, we need to make one change to the Docker Compose file, which is to add a depend on section to express the dependency between the Redis service and Docker app service. Let's start by checking out the source code first. Just do git stash and check out v1.0 tag. Then open up the prod YAML file. The first change we need to do is to add a depends on service to express dependency between our Docker app service and Redis service. So the Docker Compose app will start services in dependency order. In our case, Docker app service was started after Redis. We should have added this section earlier to ensure the right service startup order. Next, let's add the overlay network. Because we're going to deploy the containers to multiple hosts, and the default Docker network only supports single host network. So we need to define our custom overlay network. Overlay network is a type of Docker network which supports multi-host networking. Here we just give our custom network a name. Let's say MyNet. The overlay network allows multi-host networking so that the service can be linked, even if these are in different hosts, as long as they're in the same network. So we just need to add our Redis service to the same network, MyNet. Lastly, let's define our custom network, MyNet. The network driver we use here is Overlay Network, which supports multi-host networking natively out of the box. Just save the prod YAML file. Now it's time to run Docker Compose up to initialize the overlay network and start up the containers. After the containers are started, let's run Docker PS. As you see, we have our Docker app container running on the slave host and Redis container running in the master host. This scheduling is done automatically by Swarm using the scheduling strategy we choose. By default, it is using the spread strategy, which should pick the node that has the fewest load. What if we want to schedule the Docker app container to always run on the master node? The solution is to apply a constraint filter to the Docker app service. Let's add an environment section and ensure the Docker app container always run on the master node. Now let's save the YAML file and spin up the containers again. See, the Docker app container is running on the master node this time. This is the last lecture about deploying our Docker app on Swarm cluster. As a friendly reminder, if you don't want to use any revamps on DigitalOcean in the future, you should destroy them. Otherwise, they will cost your money. Don't just shut down them, because powered-off VMs will cost money as well. Make sure they're destroyed. That's it for this lecture. I hope you've enjoyed it.